the holy grail of seismology. Can we finally predict earthquakes? What if I told you that in 2023, an AI system correctly forecast about 70% of earthquakes 1 week ahead during a 30-week real-time trial in China? And still, many scientists say reliable individual earthquake prediction remains out of reach. Today, we'll unpack what's real, what's hype, and 5 advances that are changing how we live with seismic risk. The AI that broke the mold. Researchers at the University of Texas at Austin trained a model on seismic features to make weekly forecasts. In the trial, it successfully predicted 14 earthquakes within 200 miles, 220 kilometers of where they occurred and near the correct magnitudes. Missed one and issued 8 false alarms. The approach took first place among 600 teams in a Chinese competition. This is pattern recognition on real-time seismic noise, not a physics-based crystal ball, so uncertainty is inherent. Quick reflection: if a system gave a credible probability of a quake next week, how should a city respond? Tighten readiness or evacuate? That trade-off between missed events and false alarms is the core policy challenge. 2. The planet's hidden nervous system. Distributed acoustic sensing, DAS, turns existing fiber-optic cables into ultra-dense seismic arrays, thousands of virtual seismometers along a single strand. DAS has detected subtle urban vibrations and volcanic signals, and it extends coverage to places traditional stations miss, including underwater corridors. The flip side, enormous data volumes that demand advanced analytics. 3. Seeing the ground breathe from space. Satellites using INSAR can track millimeter-scale ground deformation over wide areas, revealing where strain is accumulating or where the crust is relaxing after an event. They observe displacement, not stress directly, but when combined with other data, they offer powerful situational awareness across faults and entire regions. 4. Chemical and electromagnetic whispers, with caution. Scientists continue to study radon and other signals that sometimes change before earthquakes. Some studies report anomalies days to weeks before events. Others do not. The evidence is promising but inconsistent. So these are best treated as research signals to be fused with other observations, not standalone alarms. 5. Forecasting versus prediction, the paradigm shift. Many lines of evidence suggest that precise individual event prediction may be intrinsically unachievable, given chaotic fault dynamics and decision-theoretic limits. The field is therefore moving toward operational earthquake forecasting and early warning, managing probabilities in near real time and acting on seconds-to-minutes alerts that can trigger safety automations. For example, slowing trains, pausing elevators. What this means for preparedness. Instead of asking, when exactly will the big one hit, the actionable question is, how do we design buildings, plans, and systems to handle the range of events our region faces? The future is better forecasting plus rapid warning plus resilient design, not certainty. So while we may not yet hold the keys to perfect earthquake prediction, science is giving us sharper tools than ever before. From AI systems scanning seismic patterns to fiber-optic cables listening to the Earth's whispers, and satellites mapping ground shifts from space, we're entering an era where minutes of warning or weeks of probability forecasts could save countless lives. But remember, technology is only half the battle. The other half is awareness, preparation, and resilience. The question isn't just if an earthquake will happen. It's when and how ready we are when it does. If you found this fascinating, you'll want to check out Disaster Research Note's other videos where we explore real-life disaster stories, survival strategies, and the latest breakthroughs in disaster science. You'll see how nature challenges us and how we can rise to meet it. Stay curious, stay prepared, and as always, let's learn to live with nature, not against it.